chapter 4 starts our nice little trig functions. So we're going to start with section maybe 4.1a, and we're going to look at angles and radian measures. Alrighty. Right. So when it comes to, I need a podium. I need something. All right. So when it comes to our angles, let's like make a little XY coordinate plane, right? Just to sit there and to figure out all of our little terminology when it comes to an angle. So an angle is made up of two sides. One is called our initial side, and the other one is called our terminal side. So our initial side is the side of the angle that we start with. Initial means like beginning. And we always put that like starting at the origin. And the part at the origin we call the vertex, because it's a turning point, kind of like in a quadratic, that one, bottom point or the top point, that maximum or minimum is called a vertex, because a vertex is a turning point. So when it comes to our angles, our origin becomes our vertex where our turning point is. And then going down like our x-axis to the positive this way, this is always going to be our initial side. So this is always going to be the side where we start our angle from, right? So that would be like our 0 degree. And then we just got to pick and choose wherever we want to end our angle. So just for the fun of it, I'm going to say that my angle goes to right there. So that's where I'm ending. So that would be called my terminal side. And terminal means end, right? Like if you, unfortunately, if you're terminally ill, it means like that illness doesn't have a cure, right? Or if you go into the airport and you go to get on the terminal, right? The airplane luckily cannot come into the building, so you have to get to like the end of a building, right? Or the outside of the building in order to get onto the plane. So it's the terminal side, right? And then we sit there and we name our angles. So technically on here, there's two different angles going on. Like if we think of this, right, as our angle, we could either go this way or we could go this way, right? So anytime when you draw out an angle, there's technically two angles going on. So we have to always be able to mark which angle we're talking about, and you just do it like with a little arrow in the inside. So I want to talk about the angle that's in the middle or in the inside. So I just kind of like start at my initial side and I just draw like a little angle. Maybe I can draw a little angle. Type thing. So that's telling you're talking about like the inside of the inside part, not the outside. And so this is our actual angle. And we like to name our angles using Greek letters. So let's talk about a few little Greek letters. So this way when you guys go on to college, if you go to sorority or fraternity, you'll know all of these, right? Usually a lot of times in trig, probably the most common one we use is this little guy. And this is alpha. Right. Anybody know what's after alpha? Beta, yep. So it's almost like a regular B. It just has like a little tail at the beginning of it. So I almost draw it from like the top, from the bottom. I just kind of come up and then make the B on top. And that one's beta, yep. And then sometimes and usually if we're just dealing with two angles, we just use alpha and beta. Sometimes if we want a couple more, we take our alpha and you put it on its side. And it looks kind of like this, and this is called gamma. And in science, you guys have talked about gamma rays, haven't you? Maybe? And the other nice little famous one is called theta. So you're just going to draw a circle and kind of put a little line through the middle. And that one is your theta. And then there's, let's see if I can. Anybody know what that is? Give you extra credit if you can figure it out. Come on, man. Is my drawings that bad?
It looks like a duck.
Chicken.
Chicken?
Chicken.
Chicken soup?
Well, was it?
Chicken pot pie.
Yep. Chicken pie, pot pie. There you go. Chicken pie, pot pie. That's chicken pie, pot pie. Yeah, yeah. It was the sorority I was a part of. Come on, man. You guys' humor didn't come with you. Come on. Let's have some fun with this, right? All right. So on my little angle, just for the fun of it, right? So then I just label it, and I'm going to call it like theta. So I just put that little theta like in there, so then I know that that's the angle that I'm talking about. All right.
My dad literally called Mr. Air like 3 times to get them to stop. They do it during exams.
Nice. All right.
They're working on upstairs, like the new office and stuff.
But that's that end. I think this is.
That's all, but they're still moving it around. You get to fit over there. It's like they're gonna move desks all the time.
All right. All right. So let's say we have this little angle. Here's our little terminal side. Or sorry, our initial side. And here's our little terminal side. And I want to go from like here to here. Oops. And I don't know. What do we want to call this one? Alpha? Oh, that didn't curve. Some days. And this here is our alpha. So since I went to the left from the initial side, or because I went counterclockwise, right? So if we think of this as being a clock, right? My initial side would have been like at 3 o'clock, and I went from 3 o'clock and I went back to, you know, I don't know, 10 o'clock, right? I went counterclockwise. That is going to give us positive angles. Anybody want to make a educated guess on what that angle might be? How many degrees? Take a wild guess.
More than 90, I know that.
More than 90.
145.
145. 135.
120.
120. Somewhere around there, right? So we got 120, 135, 140. I'm going to go with 132. Make you guys all happy, right? Just a rough little guess, right? Is it 132? Probably not exactly, but we're close enough, right? If I looked at that same measurement or that same angle, that same initial side and that same terminal side, but let's say instead of going counterclockwise, I wanted to go clockwise. So anytime I go clockwise, so I always kind of think of it, my initial side is at 3 o'clock, right? And then I went down and around. This is going to give me what kind of angles? What do you think? Negative angles, yep. This is my negative angles. And then we just got to try and figure out maybe what this angle is. Okay. So we know from here to here is how many degrees? 90. Here all the way to here is going to be 180. So then we just got to kind of like figure out that other little piece. 45, okay, yeah, so how much would that be? Approximately. 225. And then we know that it's going to be positive or negative? Negative, so it's going to be negative 225 degrees.
Do we have to label that as alpha, beta, gamma, or theta?
Oh, sure. Which one do you want to use?
You can just pick any of them?
Sure.
Oh, okay.
Which?
Gamma.
Gamma. I like gamma. Let's go gamma. So then we're going to call that gamma. Yep.
So why do you label them in Greek letters like that?
What else you going to use?
You can literally just pick anything though for them. It doesn't mean
Yeah,
anything.
yep, yeah. And usually it's like it's in the problem, like the problem will tell you, you know, so, yep. Yep. All right. So when it comes to our nice little angles, we can take all of our little angle measurements and we can apply these to these famous little shapes called circles, right? And when it comes to looking at circles, we talk about this thing called radians. So by definition, and we'll go over a picture of it, sometimes the picture is a little better, but it's the length of the intercepted arc divided by the circle's radius. And we're like, what? So we're going to draw a cute little circle. That's an oval. And I'm really bad at drawing shapes, so we use our imagination a lot in this class, just in case you were wondering. Okay. So I know from geometry you guys remember some things about circles, right? And how to draw angles in circles a little bit, right? Anybody know where we might want to put our, how do we name circles? Anybody remember? You actually name them by their center, right? So we're going to draw an angle from our center. So it's going to get a little sloppy. But remember how we had like our XY coordinate plane? Remember that guy? So that center would be our vertex, right? And then we have our initial side. And our initial side always follows down that positive x-axis. So here would be like my initial side of my angle. Oop. And angles can continue, so we can just draw a nice little continuation. And then, wherever we want to draw it, I'm going to go here. Right? And then that would be my terminal side. And I want to talk about that little angle right there. So when it comes to our circle, we can name a couple little pieces. So from here to here, what's that called? Or from here to here, what's that little piece called on the circle? The radius. Yep. So there's where your radius is, right? So we can put an R here and we can put a little R there. So by definition, remember our radian equaled, right, the length of the intercepted arc divided by, so divided by the center's radius. Usually we just use R for the radius, right? Anybody know where that intercepted arc is? Yeah, this is your intercepted arc, this little guy from here to here, right? So there's a relationship if it comes to when we're talking about that radian or that angle, there's got to be a relationship between the radius and then like how big of an arc we have, right? Because that's going to sit there and help with that angle that's in there. So this would be our length of our arc. All right, how about we go arc length? Oop. So if we had a crazy little triangle or circle, right? Then we have our initial side. And so we got some other little angle going on over here. Now I want to talk about from here to here. No, I'm just going to name it theta. Because for me, theta is the easiest thing to draw. It's just a circle with a line through it. Right? And I don't know, let's say our radius is 6 centimeters. And our arc length was 15 centimeters. So if I want to find that radian measure, right, so find the radian measure of theta. So our theta is going to be our arc length. What was our arc length? 15 centimeters. Over our radius, what's our radius? 6 centimeters. Right? So what's that going to reduce down to? 5 over 2 radians. So in other words, our proportion or our ratio for our arc length to our radius is a 5:2 ratio. Right? So we're just going to start off like today, kind of just messing around with these, and then we'll start getting into how does this all apply. Right? So there's a relationship between, remember how those angles and those degrees in the radian. So we need to be able to go back and forth between degrees and radians and degrees. And I think we started this last year. Right. So the relationship, they've been dating for a while. So between degrees and radians. So remember our little circle we had, right? And then my initial side is going to go from the center, thinking of that nice little x-axis, right? Positive x-axis. And I actually now want to go all the way around. So that's how you can tell the difference between 0 degrees and 360 degrees. If I would have just drawn the line, that initial side, and I didn't draw any of the little angle part of it, then that means that's the only angle I'm looking at. And there's no little roundabout angle, so it's going to be 0. But on this one, because I drew it all the way around, I know that I'm talking about 360 degrees, right? So let's see if we can figure out our theta for 360 degrees, right? So the arc length, so we want to know the distance all the way around the circle. Anybody remember what that's called? It starts with a C. The circumference, yeah. Anybody remember how to find the circumference of a circle? 2 pi times the radius. Yep. And to find our radians, remember it was the length of the arc divided by the, what do we divide by? Radius, yep. And what's our radius for our circle? It's going to be r, right? So we can actually reduce this. What's going to happen to our r's? R over r is 1, right? So it's going to equal 2 pi. Bless you. Anybody know how many degrees it takes to go all the way around a circle? How many degrees? If you spin around in a circle, how many degrees did you go? 360? Yep. Come on, guys. Okay. So for 360 degrees, we just found out how many radians was that? 2 pi. Right. Could we figure it out for 180 degrees? How did we go from 360 to 180? What did we do? Took half of it, right? So how many radians do you think 180 degrees is going to be? How do we go from 360 to 180 again? You took half of it, right? Right? So how many radians is it going to be? 1 pi, right? It's going to be half of this. And what's half of 2 pi? Pi, right? What about 90 degrees? How'd you go from 180 to 90? What did you do? Take half of it, right? So what's half of pi? Half of pi, or pi over 2, right? Uh-oh, we're gonna get fancy. 45 degrees. How'd you go from 90 to 45? Yeah, how many radians? Good job. Yep. Pi over 4 radians. Yep. So that's great when it comes to, you know, these nice little easy ones, right? We just took half, 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 right? We could take half of 45 and keep going. But I bet you there's a whole bunch of other angles in between those. And we want to know how to be able to go from degrees to radians for, let's say, I don't know, like 200 degrees, right? So we have some little conversions, right? So if we want to go from degrees to radians, it's going to be your whatever the degree is that they give you, and then you're going to multiply that by, whoops, it's a really bad one, by pi over 180 degrees. And that's going to give you your radians. Okay. I don't like this color. Try that one. So let's say you had 30 degrees, right? So how many radians is 30 degrees? So what are we going to do? 30 degrees times pi over 180 degrees is going to give us our radians, right? If it makes you warm and fuzzy, you can throw that 30 degrees over 1, so you get that fraction times a fraction. You can either multiply it out or cross cancel. I like to cross cancel, right? Does 30 go into 180? Like 6 times, right? Our degrees cancel. So now what am I left with? What do I have on top? Pi divided by what's on the denominator? 6 radians. Yeah. And that gives us our exact value, and we want to leave it with the pi on there. Yep. So 30 degrees is pi over 6 radians. You'll have these guys memorized in no time. What if we had negative 135 degrees? It's going to be the exact same thing, right? So 135 degrees times pi over 180 degrees, and that's going to give us our radians. Oop, negative.
Bitch.
Yes.
Is there supposed to be like an equal sign between the radians and like the other part?
Nope. No, because we're just simplifying it. Just doing the conversion from one to the other.
Okay, so when you put the radians, like the word radians, is that just like a tag? Like
Yes. Yeah. Yep. Yep. Because like technically your degrees are canceling, and then you're going to be left with radians. So when we switch it the other way, you're going to have radians written twice and degree once, and then your radians cancel out.
Oh, okay. Sweet, thanks.
No problem. So we can reduce this, and we're going to get what? Negative, 3/4 pi radians? If I reduce the right way. Did you guys reduce it to 3/4? Or did you just wait for me? So here was going from degrees to radians. And so guess what else we got to do? Radians to degrees. Right, last one. So radians to degree. So on this one, whatever they're going to give us, the radian, and then we're going to do just the opposite. We're going to times it by 180 degrees divided by pi radians. Right? And on this one, technically our radians are going to cross cancel, right? And then we're going to be left with our degrees. So let's say they gave us, I don't know, let's go with pi over 3 radians. So what degree is pi over 3 radians? Well, we got pi over 3 radians. And we're going to multiply that by 180 degrees over pi radians. Pi radians cancel. 3 goes into 180 how many times? 60. And what are we left with? 60 degrees. What if we had negative 5/3 pi radians? And if it helps, you guys don't have to write out the word radians. All right, so this would have been negative 5/3. And I just always throw my pi on top. And what am I going to multiply that by? 180 degrees over pi. Pi over pi, those are going to cancel out, right? That's 1. 3 goes into 3 once. 3 goes into 180 60 times. Don't lose your negative. We still had our negative. 5 times 60 is 300 degrees. Negative 300 degrees.